We'll be looking at Portland Public Schools sustainability standards. This is our second panel in a two-part series. The first panel looked at the district goals and the process of developing the standards, and this one will dive into a little bit more of the nuts and bolts of the standards and project requirements. This is presented by the Portland Green Schools Committee. We are a dedicated group of volunteers committed to creating healthy and sustainable school environments. We'd love for you to get involved. Our next meeting is actually tomorrow at noon. So feel free to reach out to us by email, by signing up for our email list, and we'd be happy to have you. Those are our links. With that, I'll pass it off to today's presenters. We have Erin Pressberg from PPS, Riley Loveland from New Buildings Institute, and Ruan and Forrest from PAE Engineers.
Hi, everyone. My name is Erin Pressberg. I work for PPS. Thanks for joining us. So today we're going to go over more of the detailed part of the energy and sustainability standards that we developed. Next slide, Natalie. So quick agenda, we're going to split this up into 3 sections. So first we'll talk about defining the standards, and then the project process and the project requirements. So section 1, defining the standards. Next slide. A little bit of a recap from last time. So just wanted to put these up here for anyone who wasn't able to join us. This was really the driver for our standards. We set out these goals, the sustainability goals, and the standards were just one piece on how we're going to get there in the next 20 years. Next slide, please. Here's the baseline EUI by site. So our goal is to get to 30 kilobtus per square foot per year by 2040. And as you can see, most of our sites are well above that. Some of them even more than twice as high. So we have some work to do, but this is just a snapshot of where we are at majority of our sites. Just as a reminder, I'm stealing this slide from Ruan today, but energy use intensity is the annual thousands of British thermal units divided by the building area per year, and it's more of like MPG for your building. So it's a way to compare buildings across your portfolio. Wanted to throw this in there too, because this was really a driver on how we formatted the standards. So when we were splitting it up into building systems and different requirements, we were like, okay, let's look at building end use for schools. And as you can see, a big portion of the building energy use for schools comes from HVAC. And we'll talk a little bit later about that section and lighting and plug loads and how all of that fits into the standards. Another reminder from last time, these are our EUI targets for new construction and modernizations. So we split these up by building type. And then depending on if it's a new build or a modernization, we have different targets. So this is just an easy matrix to look at where we are at our baseline, which is the fiscal year 2018-19, and then where we want to be for our targets and to reach our overall goal of 30 EUI by 2040. One last review from last time, just some overarching goals and targets that we set as part of these standards. We were already going for LEED certification on our buildings, but we're just calling it out now in these standards. So LEED Gold for new construction, LEED Silver for modernization. Something we did add, of course, were the EUI targets, and we're also pursuing all electric buildings for new construction. And Ruan's going to talk a little bit more about that decision and the benefits of doing that.
Yeah, thanks, Forrest. Sorry, Erin. If you go to the next slide, thanks. So we decided that adding having a requirement for all electric to go all electric on the new construction was important, because when we focus on sustainability and really we talk about net zero energy, what we're really targeting is at the heart of it, what we're targeting is climate change, right? And carbon reduction. So to get to that end goal, we really need to go to all electric buildings. There's a lot of cities and jurisdictions around the country have gone down that road. But what we see if we go to all electric is significant site energy reductions, particularly when we go to heat pumps for heating energy and also for domestic hot water. And where you can, eliminating that gas service, we've seen some projects where we were able to eliminate just the gas connection, and that resulted in a huge, just a first cost savings in the first place. So that was just a benefit to the first cost. I mean, there are of course complications to that, particularly when you start talking about other process loads like kitchens, where you're traditionally used to using gas for your stoves and stovetops and things like that. But we've done electrified kitchens as well, so it's something that needs to be discussed at the early on in the project, because once you're able to take the gas service away from HVAC systems and domestic hot water, then sometimes the gas is only for the kitchen, right? So if you're able to convert that kitchen to electric, you can take the gas all out and not have that service to the building at all. The benefit that this provides, of course, and many of you know, is that the electrical grid is only getting greener over time. And from a site perspective, you're also able to produce electrical energy through solar PV on site that can offset some of the carbon emissions that you're producing, on site. So if you go to the next slide, Natalie, this is just from 2018, just from the Energy Information Administration, that shows, the transition away from fossil fuels. This is at the utility scale in the U.S. Just a transition away from fossil fuels and more towards renewables, and which results in less carbon footprint on the grid. And if you go to the next slide, if you just look at locally for PGE and Pacific Power, for example, what their projections are for greenhouse gas emissions, significant drop over time, and that's their plan, right? So we need to be getting our schools on all electric if we really want to have a major effect on our carbon footprint. Go to the next slide, Natalie.
Thanks, Rowan. So section 2, we're going to dive into the project process. So the standards are kind of split into 3 sections. One is the overview summary, which includes the goals. And then the other 2 sections are the project process and the project requirements. So this was covered last time, but just to, reiterate, we have multiple different types of projects that are covered under these standards. We're focusing more on the new construction and major modernizations as part of this conversation today, but we're also covering our facilities retrofit, the smaller projects, and then eventually we'll be rolling this into our maintenance and operations plan as well. So one thing that we kind of figured out, halfway through this process is we really needed to align this with our technical specifications. So these standards, they took kind of a while to figure out exactly what they were going to look like, how detailed they were going to be. And we finally decided that they needed to be more of an overarching document that lived in our design standards. So it's very process oriented, high level project targets and requirements, whereas our technical specifications, if you think of division 22, 23, and 26, those are very single disciplinary, very detailed specifications. And something that we realized is our HVAC specs called for natural gas boilers. And we're like, okay, well, if we're going with all electric buildings and we're trying to hit these EUI targets that might require something more efficient, like a heat pump system, but we need to change that language. So with that said, we hired PAE to do that work as well. So they came in and helped us revamp our MEP standards, and we were able to get those a little more aligned with the sustainability standards. So the process. So these are the big categories that we outline in the standards as far as the process goes. So we'll be looking at integrated design, how this fits into Energy Trust of Oregon, new buildings program, life cycle cost analysis, commissioning, and including building envelope commissioning. So I'll hand it off to Riley to talk more about integrated design.
Thanks, guys. Hello again, everybody. So I just want to frame this conversation. I mean, all of these are important parts of the process, but the integrated design process, which I'm sure is familiar to many of you that are on this call, it's such an important part of this because it keeps you iteratively understanding what's going on, includes all of your stakeholders, and it just includes a way to make sure that you are constantly aware of what your goals are and where you are in the process. So to do that, we'll be hosting an integrated design charrettes early in the process, engaging all the perspectives in the room, making sure that you're really able to level set and understand what goals you have, what goals people might have that needs to be brought to the table. And then this process continues throughout every design iteration. So every key checkpoint in your design process, integrated design, and the different systems and the building design and the use and the climate, as you can see here, is all brought together at each of those checkpoints. And of course, conducting pre-bid and pre-construction meetings. Next slide, please. One of the most important process or parts of this in your streamlining of this process so that integrated design doesn't get out of control, or you just make sure that everyone is able to communicate effectively, is of course making sure that energy efficiency and the sustainability standards as a whole are incorporated into the overall process in a written and documented way, and that you're establishing this rapport, I really love that word, with both your internal and your other project teams. I mean, it's not just PPS involved, it's all the designers on this call and everyone else. And what's extremely important is finding synergies with other projects. So communication, making sure that even though this project is happening over here and has this project team, combining that and letting people know what you're doing over here, you may not have to do something twice. So just making sure that you're constantly communicating with your own teams and other teams involved in construction in Portland Public Schools. And then in the overall process, this actually speaks a little bit more to retrofits more than new construction, but identifying and capitalizing on that low-hanging fruit. What's easy, what will give you the biggest bang for your buck, what is free? I mean, a good free option might be passive design, things like that. So just making sure that you're constantly communicating, you're finding those synergies, and you're establishing that rapport so that there's constant communication. Next slide. And then of course, PPS as part of this process has some language that they'll be pursuing the most aggressive Energy Trust of Oregon offerings, which is currently the whole buildings. And that gives us financial support for a lot of what I was just talking about and a lot of what the others will talk about with the integrated design charrette, energy modeling, commissioning. We're really fortunate that in Oregon, we have such a robust program that helps us through this process. So PPS will continue to pursue the highest level of Energy Trust of Oregon. Next slide. And I actually think I pass it off.
So yeah, thanks, Riley. Yeah, so all of these processes that Aaron and Riley talked about are, so things that we, recommendations that we put into the sustainability standard. And I should mention, and I think Aaron, you might have forgot to mention, is, PPS already does this, right? And all of these processes going through ETO incentives, doing the early charrettes, the life cycle analysis that I'm going to talk about, they already do that. So they're already on top of the ball. But this, what we really wanted to do is just get this documented. So it's in the standards, it's written down. So there's no kind of wriggle room, I suppose, next set of designers that's going to be working on the next set of projects. But so yeah, all that combined, life cycle cost analysis is very important. On the projects that we worked on with PPS, it has been a driving factor in making decisions. And so we're not making decisions at, PPS projects, of course, value engineering is going to be a key factor. Getting the budgets down and, getting the costs to meet the budgets is going to be a factor. But making decisions on design conditions, not based on just first costs, but looking at operational costs over the next 30 to 50 years, the maintenance costs, replacement costs, all of that, as well as like soft benefits like thermal comfort and health, right? So those are all going to be important. So these early analysis and life cycle cost is going to be a very important thing to do when making decisions. So the next thing that we wanted to include as part of that process, if you go to the next slide, Natalie, is commissioning. So both, systems commissioning is of course part of the process. Once we get our building built, we want to make sure that it goes through a very thorough system commissioning process to make sure it works properly. But also, building commissioning during the design process. So the commissioning agent is on board early on and making sure the design documents are in line with the OPR. But when we're looking at some of these options, when we're trying to potentially go passive, or we're looking at envelope improvements, getting the envelope commissioning is very important as well. So doing blower door tests to prove out some of the specifications that you architects are putting into the specs to meet some infiltration requirements. On some of the older projects, older buildings like Franklin, these 100-plus-year-old buildings, it was really important to do some blower door testing early on during the design to understand where the leakage occurred. And so then you can target some of the design improvements to where that leakage occurs. So that envelope commissioning and system commissioning is really important. If you go to the next slide. So, just summarizing all of these processes, having done that early conceptual energy model, really quick, really tight, just to inform the design, then revising that energy model as we progress through the design, just to make sure as the design changes, things happen, you have VEs, but making sure we're still on target to meeting those goals. And then doing the commissioning, like I said, both in design and construction. Sometimes, having mock-ups of the envelope built, so you can test that envelope during the design process and making sure you can make some on-the-fly changes before everything's covered up. And that we've found that that's been important as well. Next slide. All right, I think Forrest is going to take this on, right?
Yep, thanks, Ron. Next slide, please. So now that we've talked through the process that's outlined within the sustainability narratives, we're going to go a little bit into the project requirements and highlight some of these requirements with a potential modernization example. So within the overall requirements, we do have specific sections for each of the major systems: building envelope, HVAC, your water systems, your plug load, and major equipment in your kitchens, lighting controls, and then how to approach PV. So next slide, please. Within each of those sections, we have specific guidelines laid out in the sustainability standard itself. And then we have references to the technical specs for the details of the target requirements within that. And so this just outlines, within each of those segments, what are the type of things that we're pushing the projects to, or what are we guiding the projects around with the major systems in the buildings. So next slide, please. These are high level, the details that are within the specs for these individual system requirements. I'm not going to go through each of these. The specifications and the sustainability standard are available for everybody to see, so you can review these in more detail. But it just highlights here some of the key things that we're looking at. On the envelope construction in particular, our main focus was the air leakage of the buildings and trying to get that down below what code allows. And particularly with modernizations, looking at ways to improve the existing envelope with air saline measures. The window performance values are better than what code would require. Obviously, your window is your weakest point within your envelope. So if we can tighten that up some and use kind of available best systems for our windows, we can really tighten up our losses to our envelope. Over our walls and our roof targets are in line with the current code. Code has already pushed that about as far as you would go with a standard design. If you're looking towards more of a passive house design, where you're really trying to tighten up and minimize your loads, you can go beyond that. But for base target, we are just looking at code performance for the wall insulation and roof insulation values. And then on the HVAC measures that we're looking at, once again, as Ruan mentioned, really targeting all electric options for our heating systems, looking at decoupling our ventilation and providing heat recovery on the ventilation. So we're reducing that major building load within the schools. And then, with new buildings and even additions that, you have an opportunity to leverage more of a passive design, looking at those higher levels of insulation and looking at a kind of case by case basis to find the best cost benefit for the project. And then within larger volume spaces, kind of best design practice, looking at systems with ceiling fans and radiant heating that just provide better comfort within the spaces and are a very good low energy option in some of those spaces. And then going on to the plumbing measures that we're looking at, these are pretty standard in most designs at this point. But just targeting the low-hanging fruit, as Riley mentioned, get the stuff in that just makes sense from a cost standpoint. So really bringing down your loads of your fixtures and looking at how you're addressing the demand. Go to the next slide, please, and we'll go through the example and get into these a little more detail. So lighting measures that we're looking at here. Once again, we looked at kind of best in class designs. What are typical targets that we would see on lighting? These are pretty aggressive. They are beyond what the new Oregon Energy Code would require. So we're really trying to push all LED lighting design, and these are very attainable targets for most projects. And the reality is, when you get to these levels of lighting, it's all about your layout, and you can actually reduce down the number of fixtures that you're installing and reduce your overall cost while achieving a high performance design. It's just how you lay it out and how you address the light levels within the space. Plug loads, there's a lot of equipment that's available to bring down your overall plug load energy. The kitchen is kind of the linchpin within that. These larger buildings that have a kitchen that's essentially a production kitchen, it's a high energy use intensity space. So looking at all electric options, not only are you tying to a more efficient grid, but you're also tying to more efficient appliances. Induction cooktops are significantly more efficient than the gas cooktop as are some of the other available electric appliances. And then with all of the plug loads, where available, the most efficient operating mode is off. So integrating controls to where you're able to shut those off so they're not just running when they don't need to be. And then the last piece of this, once we've addressed everything within the building systems and our efficiency, really targeting the best approach for the solar PV on the project. So all of these projects are currently going to be under the 1.5% green energy technology. So making sure we're looking at how to address that on a overall program level for the school district, but prioritizing the best sites for the PV and getting the most bang for our buck when we are looking at incorporating PV into these projects. The next slide, please. Now, as I mentioned, I wanted to go through, to highlight these specifications, how this would kind of play out in a modernization project. And so, this is just a hypothetical large high school with a historic building facade. So there's project. It's already tied to gas heating and gas for the kitchen. So, totally eliminating gas service may be a little bit of a challenge. We won't see that cost benefit that Ruwan was mentioning earlier, but there are still things that we can look at towards that. So overall target for this project, based on what we've laid out for the modernization targets for high school, is going to be a 35 kBTU per square foot per year. So next slide, please. Going back to the envelope and how we would address the envelope and why we really want to focus on the envelope within this modernization project. Aaron mentioned in the first section of this, this is really our chance to dial things in and button things up on the envelope. Because it is a historic building, there's a significant portion of the facade that we're going to keep in place, but that doesn't mean we're not touching it. And so we have an opportunity to go in and really address the areas of concern. So, in this instance, we'd be looking at, and we highlight the energy use pie chart for a typical school here and what type of things the envelope are going to address. So it's the heating, the cooling, and the ventilation fans. So what we want to do within our project is go in and make sure we're doing a thorough assessment of any aspects of the envelope that are going to remain in place. And so that includes both thermal imaging, so looking at where we have hot and cold spots within our envelope, as well as doing some targeted blower door testing of the envelope to address potential areas of leakage. So, this is the overall process that we've laid out in the standards for what we would go through on each different type of building for addressing the envelope. So, looking for the low-hanging fruit by doing that early testing, fully assessing the envelope, and doing life cycle cost analysis of the different measures we could implement to make sure that we're prioritizing the biggest bang for our buck. And then, as we're going into the implementation, looking and going through and doing air sealing of any problematic areas. So you don't know what to seal until you've done testing. Going back to that first assessment, and as things are being opened up, doing additional testing or additional imaging to identify if you have problematic areas within those wall sections that you've opened up during construction. And then, back to Ruwan's point on the commissioning, really having somebody that's fully engaged in the building envelope commissioning. So they're looking at, what are the existing drawings? Where are problematic areas there? What are the design drawings in the new assemblies? Are there any potential problematic areas within that? And then throughout the construction phase, having somebody going out and doing checkpoints and making sure that our penetrations aren't potentially problematic, that they're properly sealing around any penetrations that are being done, that the air barriers that are being put in place are truly continuous. Looking for any potential major thermal bridging issues. Once again, that's something in an existing construction that you can identify through that thermal imaging. You'll be able to see that within the thermal imaging. And then, in construction, doing additional thermal imaging so you can see any problem areas that may have arisen from bridging that you put into place. So that's all about that field inspection phase, and it is a kind of continuous process throughout construction that really starts, pre-construction through demolition and all the way out through construction completion, and then doing, final building verification using blower door testing to identify any potential final items to remedy. So next slide, please. The next piece that we have the greatest opportunity in these projects to address is, we're gutting the systems that are in place in the HVAC systems with this modernization project. So we have a chance to really change out everything. I mentioned that this one's already tied to an existing gas connection for heating. But that doesn't mean that we're fully tied to boilers. project. There's still the opportunity to tie into a hydronic system using air to water heat pumps as our primary source of heating. And so, that's going to give a significant reduction on that heating energy that you're seeing there. And hopefully we've got that down from the 47% with all of the things we've done in the envelope. But with a traditional gas boiler system, that's still going to be very high. So, really looking towards that higher efficient heating option and continuing to reduce down our heating loads by addressing how we're delivering our ventilation to the building. So, wherever possible, redesigning our ventilation supply to the building using a dedicated outside air system, which has significant advantages over a traditional VAV system in that your ducting is considerably smaller. So in a modernization project, it's easier to reroute things and get things into place with a DOS unit. Additionally, you have a heat recovery system tied to that, and so all of that heat that you're wasting and exhausting out of your building, you're able to recover a fairly significant portion of that. And then, as I mentioned before, looking to tie into radiant systems where possible. If we're adding on some type of a new common area to this building, looking at a radiant system as a good option for that. Also looking towards tying into natural ventilation options, using the operable windows that are often in these buildings, but using them correctly by tying back into your HVAC system and making sure that you're shutting off the system when you do have those windows open, and kind of redesigning the air path where possible during the architectural phase, so you're actually able to get good cross flow of your natural ventilation to provide healthy spaces in the building. So next slide, please. With the water options that we're proposing, the low flow fixtures, as I mentioned, are kind of low hanging fruit. The area where low flow fixtures aren't quite enough is the kitchen, where it's very process driven, and so the appliances within the kitchen should be specified to low water use appliances, low water use dishwashers, etc. And then the domestic hot water heating, addressing that through the way that we're designing our distribution system. So having short runs for any major end use domestic hot water. So our locker rooms and our kitchens, making sure that our domestic hot water heating unit is close to the end use point, and leveraging a heat pump option for those high energy intensity loads, which once again gives you that much higher efficiency in delivering the heat needed for the domestic hot water. Additionally, if you place these right, you can sometimes tie them into an IT room and use that domestic hot water unit as a kind of free cooling for your IT equipment, by putting the condenser unit directly in the space with that load that you're needing to constantly cool. And then the last piece of this is, where you don't necessarily have high loads and a heat pump doesn't make sense, leveraging on-demand units that, most efficient option is off. So if you don't need to be heating the water, you don't need to be constantly tempering it in a tank, using that on-demand unit just to provide the hot water where needed. Next slide, please. And then with the plug load, I kind of iterated this over and over. The kitchen is the biggest challenge. With everything else, looking towards Energy Star rated equipment, with a minor renovation, a lot of existing equipment is going to be in place. With the major modernization, we're really looking to change out the equipment. So as we're changing everything out, upgrading to the more efficient Energy Star rated equipment, making sure that the way we're addressing our IT loads in the spaces is using the most efficient dedicated option, so you're not having to drive your main air handlers to provide cooling to those spaces. And then looking at tying into occupancy sensors and really forcing or changing how we're communicating with the operators of the building and how they use those occupancy sensors. You know, it is a code required item for most spaces within the school under the new code. But there's always the option to plug into another outlet that's not on that. So it's not just putting in the infrastructure, it's actually having the conversations, making sure people understand what the benefit is to it, and that it's not going to hinder your work, but rather just provide a benefit to how efficient the school operates. And then this last option is, you know, really looking to leverage that all electric cooking option. You know, in the case of this project, we're not going to be able to see the major cost benefit of completely removing a gas connection from the building. And so maybe, you know, because it doesn't pencil out from a cost standpoint on this project to implement all electric now, what we can still do is implement enough electrical infrastructure on the project to make the kitchen all electric ready. So, you know, this is the time to build that in, so you have the capacity on your system to transition over to all electric cooking equipment as, you know, updates are put into place on the project. Next slide, please. And then lighting, you know, we went aggressive on the LTDs. So you've already brought down your lighting intensity significantly from this, but still, you know, making sure that we're fully controlling these fixtures. Most new fixtures, you know, they've got a lot of controls built into them. You're able to do a whole lot more, and making sure that we're actually doing that on our projects as we're designing it in. So going through and implementing the controls that, you know, not only shut off when people are out of the space, but stay off until somebody comes and turns it on, a vacancy sensor versus an occupancy sensor. You know, with the envelope opportunities that we may have within it, you know, looking towards opportunities to bring additional daylighting further into the space, and making sure that we're controlling the daylighting in a way that we have a continuous, nice light level that best mimics the natural light throughout the day, and there aren't kind of hot spots within the lighting of the space. And then, you know, the last piece of this is, and I think a pretty big opportunity is the task tuning of the lights. This has kind of two benefits in that, you know, you're bringing down the light levels, so you're making sure the light levels meet the needs within the space. And as I mentioned, a lot of the fixtures have the built-in capabilities where it's pretty easy to do it at this point. But the additional benefit is when you turn down that fixture, you know, LEDs do degrade over time. By not operating at the full light level, it significantly extends the life of the equipment. So, you know, that's another cost savings to the project in the long run. There's less maintenance, less replacement required for that. Next slide. And then, you know, the last piece of this is the PV. So we've done everything we can on bringing down our load of their building. We're going to implement PV on the building, but make sure that, you know, our site is the right site for the PV that we're required. The district has the opportunity to balance out where those funds go. And so, you know, doing a strategic implementation of that green energy technology fund, and, you know, trading off between the different schools in the district. If this site that we're working with has a great solar resource, looking at some of the other projects that we're working on and transitioning some of the funds from those that maybe don't have a great solar resource to this one, and building a larger solar infrastructure, solar array on this project, which is a great opportunity to reduce down the overall cost of the PV system, because you get some economies of scale. You know, the infrastructure and the major connection pieces of equipment are, you know, kind of high upfront costs, but as you build out a larger system, you know, that overall cost per watt is going to go down. So, you know, it's a great opportunity there really leverage that and make sure that we're getting the most out of their PV for the overall district. And with that, oh, so I guess I kind of talked through, this, I did not fully talk through this. So, you know, this all comes back to, with everything, getting people engaged early and making sure the right people are at the table. So doing an early solar feasibility study on your site, making sure that you've engaged the solar trade ally and you understand what your resource is, so you can upfront determine, you know, how much infrastructure are we putting in on this specific project. I mentioned we think that this site is a great opportunity, so we're going to try and maximize the kWh generation on this specific facility. But you know, with the green energy technology funds, we want to make sure that we're attributing those where they're best suited. And so if it's the site feasibility isn't great, if it's lower than that 75% total solar resource factor, then you know, maybe we want to move the funds elsewhere, or maybe we want to look towards attributing those funds to other efficiencies within the building, which the DOE has, or the DOE has changed some of the requirements around that to open that up more to projects where the solar resource isn't quite there. But once again, what the district has the opportunity of kind of shuffling the funds around to make sure that we're getting the most out of it. Next slide. So just to recap, you know, what we went through on this, with the HVAC systems really targeting the heating end use reductions, addressing the ventilation, making sure we're providing a nice healthy building, and at the same time not wasting heat in providing that healthy ventilation throughout the entire building. Transitioning over to the heat pumps because they operate so much more efficiently and they're tied to that electric grid that gets greener over time. And then leveraging our natural resources. We still have a great climate that is changing, but we do have a really good climate for passive cooling, particularly in a school project where, you know, the high occupancy doesn't occur during our hottest periods of the year typically. And then with our other systems in the building, you know, addressing our controls, making sure that we're controlling off as much as possible, looking towards more efficient equipment, and then leveraging that solar to get the most out of it for this project. And recapping on the envelope, you know, this is the time to do it with this project. We want to make the historic features last, you know, another 100 years, and we want to keep this building comfortable for all of the occupants within it. So we've been stressing and talking through all of the energy implications, but obviously the thermal implications are huge as well. And that's one of the big reasons with the thermal imaging, you know, really addressing any of those cold spots that you're going to have where you would just have continuous comfort issues. And what's the point of having a brand new building that you can't be anywhere near your windows or your exterior walls because it's just cold and uncomfortable, and that radiates out into the space. So, you know, this is the time to really address it, get all of those leaks, address those, incorporate you know, different testing measures to make sure that we're getting really tightening this up and getting the most out of our envelope, because that's really the core of the building, and that's what we want to address. So with that, I think I'm going to pass it on, next slide, to Riley, or is this Aaron?
Yeah, this one's me. Thanks, Forrest. So now that we kind of went through that hypothetical example throughout the project requirements of the standards, I just wanted to highlight Kellogg Middle School. So this is a middle school that was just finishing up being rebuilt now, and it will be open in the fall for instruction. And this project was interesting because it was kind of being designed and built alongside the same timeline that we are developing these standards. So we were kind of checking in with the project team from time to time saying, hey, like, are you guys doing this? Like, does this seem feasible to you? So I I really want to highlight them today because they were able to meet some of these project requirements, actually most of them, without having the standards established yet as a district. So just a few things off the top of my head that I pulled from this project are they were able to go all electric and show an upfront cost savings by doing so. The most recent EUI modeled was 26, which is just one over the new construction for middle school target. And then they also incorporated building envelope commissioning, which proved to be really successful, not just because of the blow-a-door test, but also just through commissioning and design. And they were able to do all this within the original budget constraints, which was a huge win. So this was a really good example to show leadership. Okay, we can do this with just a little bit more formality and intention. We should be able to accomplish this fairly easily. So yeah, I'll pass it off to Rawan to talk about project budgets.
Yeah, thanks, Aaron. So yeah, one of the, we talk about this, and obviously the next big question is, yeah, that's great, but can we meet our budgets, right? How is this going to affect our budget? So a couple of thoughts on that. Like I said earlier, if we can eliminate gas service, I think this data is from the Kellogg project, right, Aaron? So we saw like a net of $100,000. We not PAE, but PPS saw a net savings of $100,000. Just going to that, we acknowledge that going to all electric, you have to look at the electrical infrastructure costs because that is going to potentially increase. But in that particular case, it was a net decrease because the cost of the gas service was significant enough, right? Going to heat pump systems for HVAC or heat pump domestic hot water is going to be a little bit of an increase. But what we found is that, Forrest talked a little bit about passive cooling, passive heating designs, where, so projects where we've been able to successfully implement that, we've early in the design process worked through with the design team on finding the really sweet spot for what the envelope improvements need to be to reduce the HVAC loads enough that we can reduce the HVAC systems, right? So you have to really find that optimized point where you're putting enough money into the envelope where it's making enough of an impact that will affect your HVAC budget and start to decrease your HVAC system size, complexity, and budget. And that will get you to a place where you can kind of try to make this happen. Lighting, we really need to have a well thought out lighting design where you're not just throwing in lighting fixtures to meet the needs, but optimally placing lighting layouts to meet the need. If you go to the next slide, a good way that we've done this successfully in the past is kind of keep it simple. Like we've done some good, better, best scenarios. In the past, we used to do tens of 20s of different energy conservation measures and look at the costs and things like that. But it really, because the envelope and HVAC systems and lighting systems and architectural design, all of that kind of play together, it really is best to look at these as these packages of what I like to call good, better, best scenarios, and package them all together. Look at these costs. And this is the example from a project that we did, kind of tweaked. It's not kind of the direct example, but this was done in SD, right? So we just had dollar per square foot numbers for envelope and HVAC, and we did a shoebox energy model just to get kind of a dollar per square foot energy cost, and it was able to get us like a payback analysis, and that was enough at that time of design to kind of drive us toward. At that point, we just need to know, okay, do you want to go good, or do you want to go best? And so that'll help the design team kind of steer toward a direction, and then you can fine tune it as you go. So going through that process it really helps as well. If you go to the next slide, Aaron, I think you're when I talk about that.
Yeah, so another thing we built into the standards was talking about the measurement and verification piece. So, we've talked a lot today about design and construction, but how do we actually verify that we're hitting these EUI targets and that we're actually on track to meet our goals? So a lot of this we're already doing. LEED has helped us, pursue the monitoring-based commissioning credits, where we are benchmarking our energy and water use. We've seen an energy code get to the point where we are required to do sub-metering. So we have all the pieces in place to really be successful in this measurement and verification process, and then to check in with the design team and the project managers on, hey, this isn't tracking, let's go and investigate, and using all that data that we have on the sub-metering to figure out what the issue is. Next slide. I also want to cover some lessons learned. So this was kind of, it was a long process. It took over a year for us to develop these standards. And, we took a lot of engagement and a lot of back and forth on exactly what we wanted this document to look like. But one thing that we knew for sure is we wanted to make this a helpful document, which I think I talked about on the first panel, but not making it just a list of requirements that is a burden to project managers and design teams, but making sure it's more of a guidebook and like a checklist that they can use along the way. Make sure that you get stakeholder buy-in. So this is not just from leadership, but from project managers and maintenance and people that are going to be dealing with these projects and these systems going forward. Something that I really took and run with is I didn't wait for everyone to really get on board. I mean, I got the go ahead from our COO and he said, just, take it and run with it. And, make sure you're coordinating and getting feedback. So I did that. And, we went through our stakeholder meetings and got necessary feedback and made sure we were incorporating all of that. Of course, I'm not here doing this alone. I'm presenting here with PAE and NBI. So utilizing third-party help for that expertise was extremely beneficial. Couldn't have done it without them. And, I talked a little bit about aligning with other documents, and not just the technical specs, but, looking at ed specs and other process guides and documents that you have in your organization or district. And then make sure that you shout your success, tell your story, something that we're doing here today. So thank you all for being here, and pass it back to Riley.
All right, I'll bring this home. I realize we don't have that much time and there are some questions, but a lot of what Aaron said with his lessons learned is that this is an effective model. It's already working in PPS. They did a project alongside of it. It's working in other districts. I have that list. It's on the next slide. I won't read it, but it is there. But you don't need to reinvent the wheel. Documents like this are already created. We have template documents that you can use and just kind of put into your district. I also recommend, this could be this recorded video, which we'll have after, will be a great training tool for, designers, and then also for, other districts looking to do something similar, so they can watch and see what this looks like. And, Aaron and Ruan and Forrest talked about how this already aligns with processes already in place and already aligns with technical specifications. It's just kind of that best scenario, that next step up. So you guys can do it too. Ask for help if you need. This crew is your resource. There are other people doing this. We'll put our emails in the chat. Definitely reach out. I think that's pretty much it. I think there is like one more slide, but
we have a recap of the sustainability goals that we're looking at.
Go through this, Aaron, if that's cool, and shut this down so we can get to questions. Aaron brought these up in the beginning. All of you can achieve these goals. The Advanced Energy Design Guide for Zero Energy Schools actually has really attainable energy use intensity targets for you as well. If you're interested in figuring out how to set your energy targets, this team is also a resource. I will just say it again. You can do it. There it is. Thank you. Good thing we had those. Thank you, guys. Please, we have 5 more minutes. So, Natalie, do you want to read questions out of the chat, or
Yeah. So we did get some questions in the chat. I think there was some questions about generators and resiliency.
Oh, maybe you should get to that, the water question actually first.
Yeah, I was actually really interested in that. So Chris asked how we can look at water use in inclusive restroom strategies, and how focusing on using toilets in restrooms will have a measurable impact on water usage and how to look at those.
Yeah, so that was something we've been discussing. Grant High School was our first design that had inclusive restrooms, so there aren't any urinals in the entire school. Benson is also designed that way. So I don't know if Ruwan, you want to weigh in, but we did have a meeting specifically around talking about the water reduction credits through LEED and how we're going to have to get pretty creative in order to meet those, because we're flushing 1.2 gallons in a toilet versus a pint or less in a urinal.
Yeah, I mean, I think the big picture is that with non-gendered restrooms, because of the loss of the urinal, to Chris's point, we do see a higher water usage. But in Benson, we were able to get, I think it was somewhere around 22 or 29%, I can't remember, water savings, even with non-gendered restrooms.
Yeah, and I'll also add from the PPS side, it's something that's very important to our students, and we've had a lot of discussion around it. And it's unfortunate that it's one of the only examples I can think of where sustainability and social justice do not line up. So it's been a kind of a tough pull there, but we've done the engagement with our students and our community, and it's something that's very important to them. So we want to honor that.
I really appreciate that, honoring students' needs and students' desires in the work that we do. I want to respect everybody's time, so I'll just give it to the panelists to wrap up with any last thoughts before we close today.
I would say just y'all can do it. And if there are any questions, you guys are welcome to just hop on right now if you'd like. There's still 2 more minutes. So I would say if you guys have any actual questions, go for it.
I am looking at the question from Chris about resiliency. I believe there is a diesel generator at Kellogg. I know, Tim, you're on the call. Sorry to call you out. If you want to verify that for us, I can't remember exactly. But yeah, there wasn't a lot of inherent resiliency built into this standard. There are some tie-ins there, but we didn't really specify that on the generators specifically. It's something our maintenance team is a little bit wary about.
All right, well, thank you to everybody for being here today. Thank you for joining us, and we will have this panel available as a presentation and slides, and always feel free to reach out to us for more resources.
Bye, y'all. Have a great week, day, weekend.
Thanks, everyone.
Thanks, everybody.